Hello, in today's video, the next video in the series of talking about pressure, we're going to be talking about Boyle's law. Now, we have three named laws that we're going to be dealing with when dealing with gases. And then we're going to combine them to form a general equation, and then we're going to specify certain restrictions and call it an ideal gas law. So the first three laws that we're going to be discussing, and I'm only going to cover two for Monday's lecture. We will discuss the Boyle's law and the Charles law. We'll need another named law and the general law in order to identify the ideal gas law. So that's where our goal is. That's where we're trying to get to at the end of this. So let's talk about Boyle's law. Well, you've all have dealt with a balloon at some point in your life. Balloons are very good examples of how these pressure laws, gas laws, how they're affected. So, or what their relations are. So, let's say I have a balloon and it has a certain volume and it has a certain pressure. The balloon is closed, so I can't input any more gas into it. And we're going to say it's at a constant temperature. So there's a lot of constants that have to happen in order for these gas laws to hold. So temperature is constant, as well as the amount of material is constant. Now, N here is generally reserved for moles. It's going to be moles here. So this is the moles of gas is constant. We're not inputting anything in. The temperature is also constant. We're not increasing or decreasing the temperature. Now, if I were to squeeze the balloon, we know that the pressure inside is going to go up. And the reason why we know that is if we keep squeezing the balloon more and more and more, eventually it's going to pop. The pressure inside the balloon is too great for the tension of the rubber. So we know we have a relationship that volume is inversely proportional to pressure. So as pressure goes up, the volume goes down, or vice versa. As the volume goes down, the pressure goes up. That's what this indicates to us. Now, a brilliant scientist, Boyle, came up with a law that had nice ramifications for this gas world. He came up with the law of P1 V1 is equal to P2 V2. This is very similar to our dilution equation, but he knew that pressure times volume, using this inverse proportionality, has to be equal to a constant. So if I had an initial pressure and an initial volume, that has to be equal to my secondary pressure and my secondary volume. This is Boyle's law. Okay? This is something that we're going to have to know how to deal with. So what would a question like this look like? So let's say I have a balloon at 22 or 2.2 atmospheres. Okay? And it has a volume of 22.4 liters and a volume of 22.4 liters. Okay, great. Let's say I reduce the volume size. Let's say I squeeze the volume of this balloon, and I squeeze the balloon, and I got a new balloon. This resulted in a new volume of 15.4 liters. In this case, I know what my secondary pressure is. I can use this equation to solve for P2. We had the initial pressure, we had the initial volume, and we had the secondary volume, so we can figure out the secondary pressure. P2 is going to be equal to P1 V1 over V2. We plug in our values, 2.2 atmospheres times 22.4 liters divided by 15.4 liters. We end up getting a value of 3.2 atmospheres. Now let's make sure that this followed along with our thought process. We squeezed the balloon, we reduced the volume, our pressure should have gone up, and it did. It went from 2.2 atmospheres to 3.2 atmospheres. So the gas law makes physical sense. You can perform this experiment on your own. You can squeeze a balloon, and if you had a pressure gauge inside there, you could read the pressure going up. So this is Boyle's law. It's one of our three named gas laws. That's all I want to say about that. We'll do a lot of practice problems with this tomorrow, and I will see you all in class tomorrow.